There's a math problem that physicists have tried to dismiss for 20 years. They can't, and the conclusion of that math problem is this. Statistically, you are more likely to be a simulation than a real person. Not maybe, not it's possible, more likely. Here's the argument, and it's shorter than you'd think. Imagine a civilization advanced enough to run perfect simulations of entire conscious minds, not video games, but actual self-aware beings who think they're alive inside a computer. If that's possible even once, that civilization wouldn't run one simulation. They'd run millions, testing history, testing outcomes, running ancestor simulations just to see what could have happened. Now do the math.
If simulated minds outnumber real ones by millions to one, and you're a mind wondering whether you're real or simulated, the odds say you're probably one of the millions, not the one. Read that again, because most people let it slide past without registering what it actually claims. This is called the simulation argument, and it was formalized by philosopher Nick Bostrom in 2003. It's not a thought experiment about whether simulation is possible. It's a probability argument about which side of that ratio you're most likely standing on. And here's the part that should bother you. Nobody has found the flaw in it. Physicists have tried. Sabine Hossenfelder, a physicist who has publicly torn apart dozens of fringe theories, took this one on directly. And her objection wasn't the math is wrong.
Her objection was that running a perfect simulation of reality down to the quantum level might cost more computing power than physically exists in any universe. That's a real problem for the argument. But notice what it is. It's not, this is nonsense. It's, this might be too expensive. That's a very different kind of rejection. And it gets weirder, because this isn't a fringe internet theory anymore. Elon Musk has said publicly he thinks the odds favor simulation. Neil deGrasse Tyson has put the probability at roughly 50-50. These aren't people prone to wild claims for attention. They're responding to an actual peer-reviewed argument that physicists have had to engage with seriously, whether they like it or not. Let's make this concrete, because abstractions hide how strange this actually gets.
Video games 60 years ago were a single screen, you, and a constraint problem. Now games render entire cities with physics, lighting, and crowds of independently behaving characters. The growth from that screen to this didn't slow down. It compounded. If you run that same curve forward, not centuries, just decades, the next obvious milestone isn't better graphics. It's simulating something that can think it's real. You don't need to believe in Bostrom's argument to notice the trend line points exactly where his math says it should. Here's a number that makes this less abstract. Some researchers have estimated that simulating every neuron in a single human brain at full fidelity for 1 second would currently take a supercomputer roughly 40 minutes. That sounds like a wall.
But computing power has historically doubled roughly every 2 years for decades. Run that compounding forward and the timeline collapses fast. Not because anyone's certain it will happen, but because the obstacle has a known shape, and known obstacles tend to get solved. So here's where it gets personal. If you are in a simulation, what would you actually expect to notice? Not glitches, not floating text. The honest answer, according to physicists who've engaged with this seriously, is probably nothing. A simulation sophisticated enough to fool a conscious mind would be sophisticated enough to make that mind incapable of detecting it from the inside. That's not a loophole in the argument. That's the argument working exactly as intended, which means the silence, the fact that nothing seems weird, is not evidence against the simulation.
It's exactly what the simulation would look like if it were good at its job. Sit with that for a second, because most people skip past it too fast. Now here's the twist that almost nobody brings up, and it's the part that actually matters more than the simulation argument itself. The simulation argument doesn't require aliens. It doesn't require future supercomputers. It only requires one assumption, that consciousness can run on something other than biological neurons. That assumption is called computational functionalism. Let that land for a second. It's already a majority position in cognitive science and philosophy of mind, not because of simulation theory, but because nobody has found a reason consciousness has to be biological rather than computational in the first place. In other words, the controversial sounding part isn't actually the controversial part. The assumption most people would object to is already accepted by the people who study minds for a living. What's actually still debated is the math after that, the part about ratios, computing costs, and whether advanced civilizations would bother running ancestor simulations at all, instead of, say, getting bored and doing something else entirely. This is where critics land their strongest hit. Why would any civilization run billions of simulations of ordinary, unremarkable lives? Why simulate someone scrolling through a phone at 11 p.m. instead of simulating something significant? If you can't answer that, the entire probability argument falls apart, because the argument only works if simulated minds vastly outnumber real ones, and that only happens if someone has a reason to run that many. Bostrom's answer is almost unsettling in how mundane it is. You don't need a reason. You just need it to be possible, cheap, and interesting to someone, somewhere, once. Civilizations build things because they can. Nobody asks why we have billions of video game characters living out fictional, unremarkable lives inside Skyrim or The Sims. We just built it, because building worlds is something intelligence does once it has the tools. If that's true for us, at our level, the argument doesn't need a special reason at a higher level either. It just needs the tools to exist.
There's one more counterargument worth taking seriously, because it's the one most physicists actually lean on. Maybe physics itself stops them. Maybe there's a hard limit, some law of nature that makes a perfect simulation of a universe physically impossible, no matter how advanced you get, the same way no engine can ever beat the speed of light, no matter how much fuel you add. If that limit exists, the whole argument collapses instantly. The honest answer is, nobody has found that limit yet. That doesn't mean it isn't there. It means right now the door is still open. It's worth noting how unusual that is. Most fringe-sounding ideas get closed off within a few years once someone finds the obvious hole.
This one has had over 2 decades, multiple serious physicists actively trying to kill it, and the door is, if anything, still propped open wider than when it started. So let's be honest about what we're actually saying here. This isn't philosophy anymore. It's a probability problem with your name on it. One of 3 things has to be true, and Bostrom calls this the trilemma. Either civilizations never reach the technology to do this, or they reach it and choose not to use it, or almost everyone experiencing consciousness right now is inside a simulation. Pick one. The math doesn't let you escape into a 4th option. So which is it? Nobody knows. Not Bostrom, not Hossenfelder, not the physicists who've spent 2 decades trying to make this go away. What you do know is this. Somewhere between a coffee shop conversation and a peer-reviewed philosophy paper, this stopped being a fun thought experiment and became a genuine unsolved problem in the field. One with a real probability attached, sitting quietly underneath every ordinary moment of your day, including this one. Where does that leave you practically? Not in existential paralysis. Your coffee is still warm. Your deadlines are still real to you. Gravity still works exactly the same regardless of what's underneath it. If anything, the most interesting part isn't the probability. It's what the argument reveals about a different question entirely. What counts as real in the first place? Because here's the quiet implication underneath all of this. If a simulated mind feels love, fear, pain, and curiosity exactly as intensely as a real one would, indistinguishable, identical, total, then the word real might be doing less work than you think it is. The simulation argument isn't really asking, is the world fake? It's asking whether that distinction was ever as meaningful as it felt. A pain that's simulated still hurts, inside the only experience that pain has ever had access to. Think about it this way. A character in a novel never existed, and yet you've cried at a death in a book before. Nobody asks whether that grief was real grief or fake grief. It was grief, full stop, generated by a story instead of an event. If a simulated experience can produce a feeling that's functionally and subjectively identical to a real one, the categories start to blur in a way that's hard to unblur once you've noticed it. That's the part physicists keep circling back to, uncomfortably. Not whether the argument is true, whether true and simulated were ever actually opposites to begin with. If this is the kind of question that gets under your skin, you're exactly where you're supposed to be. For now, just notice the next mundane moment of your day. The coffee, the traffic, the bored 5 minutes scrolling your phone. Ask yourself honestly, would you actually be able to tell the difference if it wasn't real? Or is real just the word we use for whatever we happen to be standing inside of, simulated or not, as long as it's the only one we've got?